Section 5-2, Bisectors of Triangles. The objective of this lesson will be to prove and apply properties of perpendicular bisectors of a triangle and to prove and apply properties of angle bisectors of a triangle. Let's first begin with our brand new vocabulary for Chapter 5. The first word is concurrent. This is where three or more lines that intersect at one point. So we would say that these lines right here are concurrent because they intersect at one point. The point of concurrency is where those lines intersect at. So for this picture, point B, this is their point of concurrency. Now we do have special names for certain points of concurrency. The first one is called the circumcenter of a triangle, which is right here at point P. The point of concurrency of three perpendicular bisectors of a triangle is the circumcenter. And we're going to go ahead and elaborate that right here with our circumcenter theorem. So point P here is made by creating perpendicular bisectors. So on each side of a triangle, we will bisect this side, and we'll bisect it with a line that is perpendicular to it. So this line right here, imagine if it kept going on forever, was bisecting the side. This line right here is also bisecting side AB. And this line right here is bisecting line BC. And you can see all these congruency markings telling you that the sides have been bisected. Now when this happens, if you were to draw a line from the point of concurrency, your circumcenter right here, to the vertex of each of the points on the triangles, each of these segments would equal each other. This is your circumcenter theorem. So the length of AP is congruent to the length of PB, which is congruent to the length of PC. And here are three other different triangles that they've drawn for you so that you can see what it could look like. It says here that the circumcenter can be inside the triangle, it can be outside the triangle, or it can be on the triangle. So this point can be located anywhere. Okay, now the circumcenter is also important because of something else. The circumcenter is also the center of the circle that circumscribes the triangle. Okay, so circumscribes means that it fits the triangle inside of the circle, and all three vertices of this triangle are on the circle. And this point P right here would be the center point of this circle. Okay, so on our first example, they're telling us here that DG, EG, and FG are perpendicular bisectors of triangle ABC, and they're wanting us to find the length of GC. So right here, the length of GC is right here. If we take a look, this line right here, GE, DG, and GF, these are our perpendicular bisectors. Point G right here, this is our circumcenter. And if you remember, the circumcenter theorem says that if you connect and you make lines with the circumcenter to each of the vertices of the triangle, then all those vertices will be congruent. So I know that length AG is the same length as BG. So this is also 13.4. And GC also goes from the circumcenter to a vertice. So this is also 13.4. So all these segments right here that go to the vertice of the triangle are all congruent. So the length of GC is 13.4. Okay, for our second example, it says find the circumcenter of triangle HJK with the following vertices. So remember, to find the circumcenter, we need to do the perpendicular bisector of each side of the triangle. So let's go ahead and plot this first. We have our first point, H, at 0, 0. So we're going to label this H. Our second point is at 10, 0. So right here. This is point J. And our third point is at 0, 6. So right here. This is point K. Okay, so let's go ahead and draw our line to make our triangle. Okay, so there's our triangle. So I need to bisect each of these sides here. Now the easiest sides to bisect would be HK and HJ. So let's go ahead and start with those. We know that segment HK right here is 6 units long. So to bisect that, we would need our midpoint to be right here, so that each segment is 3 units. And down here, this segment is 10 units long, so that means our midpoint would have to be at the 5 unit mark, so right here. Now, I don't know where the midpoint is here, but if I can connect these two lines, I'll be able to see where they're going to intersect. So let's go ahead and draw the perpendicular bisectors on this. This one goes this way. Remember, it's perpendicular, so it's got to create that 90-degree angle right here. And then our next one, our perpendicular bisector, is going to go through this point, which is also perpendicular, and it creates that 90-degree angle right there. So we know that the last perpendicular bisector is going to have to go through here, because they're all going to intersect at one point. So we can say it's going to look like this right there. And that's also going to be perpendicular. They're asking us here to find the circumcenter. The circumcenter is right here on the triangle. And the coordinate point for our circumcenter would be at 1, 2, 3, 4, 5, over 5, and up 3. So 5, 3. This right here is the coordinate point of the circumcenter of this triangle. Okay, so now that we learned about the circumcenter, we're going to learn about another point of concurrency. This is called the incenter of a triangle. This is the point of concurrency of the 3 angle bisectors of a triangle. So the way this is created is when you bisect each of the angles of the triangle. So this, and take a look at the theorem that relates with that. That is your incenter theorem. It says the incenter of a triangle is equidistant from the sides of the triangle. So notice they've labeled here all the angles that are congruent because they were bisected. And point P right here is your incenter. Now if you notice these blue lines right here, if you draw a line that's perpendicular from the incenter to the side of each of the sides of the triangle, you will notice that they're all equal. So this length right here is congruent to this length, which is congruent to this length. And that is what this theorem is saying. So if we read down here, it says, unlike the circumcenter, the incenter is always inside the triangle. And here we've got 3 different triangles. And if you notice, the incenter on all 3 of these triangles is inside of the triangle. Okay, so think incenter is going to always be inside the triangle. And also the point P here, the incenter, is also the center of an inscribed circle. Okay, for the circumcenter, we talked about a circumscribed circle. But this one right here is an inscribed circle. So this circle is inside of a triangle, and the circle touches each of the sides of the triangle. So that would make line PZ, PY, and PX. Each one of those is a radius of the circle, and point P is the center of the circle. Okay, let's take a look at our first example. We have segment MP and LP are angle bisectors of triangle LMN. Find each measure. So this line right here, LP, and MP are angle bisectors. So let's go ahead and mark these congruency marks on our figures. That way it can help us out. If LP is an angle bisector, then I know that this angle is going to be congruent to this angle. And if MP is also an angle bisector, then I know that this angle here is going to be congruent to this angle over here. Okay, let's go ahead and look at the first question. It says, find the distance from P, so from P to MN, to this segment right here. And we want to find the shortest distance. And the shortest distance is always the perpendicular distance. So if I try to draw a perpendicular segment here, I want to know what this shortest distance would be. So if you remember the theorem that we just covered on the previous slide, your incenter theorem says that the distance from the incenter to the side of the triangle will always be congruent to the other distances that are perpendicular from the incenter to the sides of the triangle. So that would be this segment right here. It goes from the incenter perpendicular to one of the sides of the triangle. So that would mean that this segment right here is also 5 units long. So this is 5 because of our incenter theorem. Question B, find the measure of angle PMN. So from PMN. So they're wanting us to find this angle right in here. Well, let's take a look at the other angles of the triangle and see if that can help us figure it out. I know this angle is 20 degrees. I know half of this angle is 50. If half of it is 50, this other half should be 50. So this whole angle here should measure 100 degrees. Okay, so I have one more angle to figure out. And if you remember, all 3 angles in a triangle should add up to be 180 degrees. Right now, I'm up to 120 degrees. So that means that this last angle, the whole angle has to measure 60 degrees. That way they all add up to be 180. But they're only wanting this angle right over here on the top. And if we remember, they told us segment MP is an angle bisector. Bisect means to cut in half. So since this angle measures 60 degrees, that means each of these angles have to measure 30 degrees. So the measure of angle PMN is 30 degrees.